So as all of you joined, so now let's start our class. Today we are going to discuss a very important topic called calculus. Especially we are going to discuss differential calculus. Now, in mathematics as well as in physics, you will find the kind of phenomenon where we are finding the rate measurement. What does it mean by rate measurement? In a very simple terms, the rate measurement stands for there are two variables, how one variable is behaving depending on the other variable. For example, if you think about the displacement of a particle, you think about the displacement. I request you, those who are not speaking, you can mute yourself. And when you want to speak, then you unmute and speak. So, for example, x is the displacement, and it varies something like this: 2t square plus 5t minus 1. For example, what is t here? Here t is time, and x is the displacement. So, as time goes by, because time is independent variable, right?
Yeah.
If you see, time is a variable which is not controlled by us. So time is an independent variable. Now, as this variable is getting changed, the displacement, which is x, is also getting changed. Now, the point is that at particular instant, means at particular time, for example, at t equal to 3 seconds, what is the displacement? You can simply find it out by applying t equal to 3, isn't it?
Yeah.
So when you need to find the displacement at t equal to 3 seconds, so that is equal to 2 into 3 square plus 5 into 3 minus 1. Correct or not?
Yeah.
So whatever the value that you will get, the displacement in terms of, so for example, the unit is meter. Similarly, at t equal to 5 seconds, t equal to 6 seconds, t equal to 7.5 seconds, you can find all these values.
Yeah.
So what we see, there are two variables here. One variable is t and the other variable is x. Now, out of these two variables, one is an independent variable. Now, as physics is a study of nature, so if you see in our phenomenon, suppose, you are running and your displacement is actually varying with this time, then, time is not controlled by us. It is an independent variable. Based on that particular time, your displacement is decided. So that is why in general, what we call that t as an independent variable. Independent variable.
Yeah.
If you recall what is independent, which is not dependent on anyone, that is called independent. And x is an dependent variable. And for the simplicity of our discussion, we are confining this discussion to only two variables, one independent variable and one dependent variable.
Okay.
A lot of things you will find. Velocity is dependent on time. Your acceleration depending on velocity. Correct?
Yeah.
Or not? These are the dependent and independent variables. If you think very minutely, when you say the velocity is dependent on the displacement, here velocity is becoming dependent variable on displacement. Correct or not?
Yeah. Yeah.
But the moment you discuss about the acceleration, in that time, at that time, the velocity become independent variable and acceleration become your dependent variable. Correct or not?
Yeah.
So the variable, whether it is a dependent or independent, that actually depends on the context of that point. What context we are discussing. Correct.
Okay.
Now, why I'm giving this background information? The importance of this background information is that whatever you see this relationship x equal to 2t square plus 5t minus 1, what I wrote, this is nothing but a function. Okay, we'll discuss in later classes the details about function, what are the conditions a function must have, and all these things. But in simple terms, what we define as a function is that it is something like this, that you have an independent variable x and y is a dependent variable depending on this x, and we are defining y equal to fx, and that is called a function. Now there are two conditions to be there to have this kind of relations to be qualified to be a function. Is that if you give a value of x, you will always find a value of y. In a simple terms, you give a value of x, you'll always get a value of y.
Yeah.
Correct?
Yes.
So the thing is that if this kind of relationship is there, that is called a function. Correct?
Yeah.
And another condition is there. We'll discuss all these things later when you'll discuss in mathematics class about that, the relations and functions, that for a particular value of x, you cannot get multiple values of y. Think about. If you look into this, equation, x equal to 2t square plus 5t minus 1, for a particular value of t, you cannot get two values of x.
Yeah.
Correct, no?
Yes.
All of you agree to me? But
Yes.
for a particular value of x, you may get multiple values of t. In fact, it is a quadratic equation in t, you get two values, correct or not?
Yes. Yes.
So the condition on function, there are two conditions, preconditions to qualify the relation to a function. So in mathematics, there is a term called relation and there is a term called function. But there is a difference between the relation and function. What are those differences that we'll discuss on that particular class where we will discuss relations and functions. But in simple terms, what we can define function as that, first and foremost is that for any value of the independent variable, that is x in this case, you will always get a value of the dependent variable y. Okay, that is the first condition. And the second condition is that for a particular value of independent variable x, you cannot get two different values of the dependent variable y.
Okay.
Under these two conditions, we define it is a function. Now, let's discuss few simple concepts in physics. If you see that displacement is a dependent variable, time is an independent variable. When you see that, same thing is that velocity, it can depend on time. Acceleration, it can depend on velocity, like that. Now, what about rate measurement? As you see in the left-hand side, what I wrote, the displacement is given by means of an equation in terms of t. We can find what is the value of displacement at different time instances. But can we say that how, as time goes by, how the displacement is actually changing? Means, in simple term, what is the pattern of changing? For example, can we say whether it is an acceleration or deceleration?
No.
Can we say whether the velocity is changing or decreasing?
No.
Now, the moment this point comes, then it's called the rate measurement. Why rate measurement? Because as time t is changing, how x is changing, that I want to know. Okay, the way the t is changing, in that way and in that manner, how x is changing. In simple terms, a rate of change of x with respect to rate of change of t. Correct or not? That we are going to discuss.
Okay.
In terms of y equal to fx, what is in simple terms is that the rate of change of y with respect to rate of change of x, that is what we are actually looking for.
Okay.
Why we are looking for? Because this is very practical. Physics is a study of nature. You think about it. You started, bicycling from your home and going towards your school.
Yes.
Now, if you want to know that if I am moving in this speed, okay, how my displacement is changing. That leads to, sorry, if you go into this, if you are crossing that particular position at particular time interval, you want to know how fast or how slow you are moving, correct or not?
Yeah. Yeah.
That is what is called velocity,
Yes.
correct? So what is velocity? The rate of change of displacement, correct or not?
Yeah. Yes.
Now think about what is acceleration, the rate of change of velocity.
Hmm.
What we know so far about acceleration? Acceleration is equal to final velocity minus initial velocity divided by the time elapsed, correct or not?
Yeah.
But if you more deep dive into it, when we started discussing about the rate measurement, it is nothing but the rate of change of velocity with respect to time, isn't it, dear students?
Yeah.
Correct. So that is why discussion of the rate measurement is so important, so practical, and there are a lot of mathematics in it, and that's what I want to discuss in the next, you know, half an hour or so.
Okay.
So let us consider now. Whenever you see that function y equal to fx, always you can plot a graph, correct or not?
Yeah. Yeah.
About whatever you are seeing in the digital board, x equal to that equation, that x equal to 2t square plus 5t minus 1. You can plot x in t in the independent variable, that is in the x-axis. Always general practice is that take that x-axis for the independent variable and take the y-axis for the dependent variable.
Okay.
So in this case, x equal to 2t square plus 5t minus 1. What you see, t is an independent variable, so you will take it in the x-axis. Then x in the, it as if like that, you draw this is the x-axis, correct? Which is the time axis.
Yeah.
And this is the y-axis, which is actually your displacement, that is the x1, correct or not?
Yes.
That is x. And then you can plot that one. What is that plot? I am not going to discuss in details now. This particular curve is called a parabola, so you will get a parabolic equation.
Okay.
So what does it mean? As we know, a picture says 1,000 words. Similarly, if we have a function, if we can give a pictorial description of that function, we can have a very clear idea that how function is moving. Correct or not?
Yes.
Clear? So
Yeah.
now as we have y equal to fx, I would like to give a, you know, you know, the pictorial description of that function. Clear or not clear?
Yeah. Yeah.
Okay. So I'm going to, plot that graph here. So just give me, few seconds to so that I can pull it here. Please confirm that you are able to view it clearly.
Yes.
Okay. So consider two quantities y and x interrelated in such a way that for each value of x, there is exactly one value of y. What I said few minutes back as a condition to be have this kind of relation as a function,
Yeah.
correct?
Yeah.
Now look into that, diagram very minutely. If you see in the x-axis, we have defined that independent variable x, and in the y-axis, we define the dependent variable y. Correct or not?
Yeah.
Now, if you look into this diagram, it is a diagram. It is a diagram represents the graph of y versus x.
Hmm.
The value of y at a particular x is obtained by the height of the ordinate at that x. Correct or not?
Yeah.
For example, if you look into the point A, for where the x coordinate is x0 and y coordinate is nothing but fx0, which is nothing but y0. Correct or not? So what
Yeah.
is that? Here we see y equal to fx, na?
Yeah.
as y equal to fx. So now put x0. So what is y0? Y0 is equal to f of x0.
Zero. Yes.
That is the coordinate of the point. So coordinate of the point is what? From our coordinate geometry concept, x0, y0.
Yeah.
Or in other terms, we can say the coordinate of the point is, it is x0, f of x0.
Yeah.
All of you agree to me?
Yes.
Coordinate of the function, a coordinate of the point A is x0, f of x0. Correct?
Yes. Yes.
Now, let's x changed by a small amount delta x.
Hmm.
Correct? And the corresponding change in the y is delta y. Let's assume this thing.
Okay.
Okay? Let x change by a small amount delta x and the corresponding change in y be delta y.
Okay.
So we can define the rate of change of y with respect to a rate of change of x in the following manner. When x changes by delta x, y changes by delta y, so the rate of change seems to be equal to delta y by delta x, correct or not?
Yeah. Yeah.
Now suppose A be a point with x comma y and B be a point with coordinate x plus delta x and y plus delta y. The rate delta
Okay.
y by delta x is nothing but equal to the slope of the line AB.
Yes.
Let me show you this thing. Let me make that right up and then show it to you what I mean by that.
And sir, could you please increase the font a bit?
Absolutely, yeah. That's what I asked before the this thing that you said. All of you said yes. That's why I did. Definitely, I can increase. Okay. Is it okay now?
Yeah. Yes.
Is it
Thanks.
okay?
Yes. Yes. Yes.
Correct, huh?
Yeah.
Okay.
Yeah.
Actually, if I increase too big, then diagram and these things may be little challenge to look into it because I want to show both.
Yes.
Now, please confirm the diagram and that text is clearly visible, dear students.
Yes. Yes.
Okay. Yeah. So now, if you look into this, what I was telling that when x changes by delta x, that means how x is changing by delta x. So this is the initial value of x, if you see here,
Hmm.
and this is the point. After that, it's changed by delta x. By the way, delta x is a very small value,
All
but to
right.
show it in a very proper manner, I give a stretched it away delta x.
Okay.
Okay. Otherwise, it is a very, very small value. Delta.
Okay.
Delta means what? Small, right? That stands for small.
Hmm.
So if you look into this statement, when x changes by delta x, y changes by delta y. So that
Okay.
the rate of change seems to be equal to delta y by delta x, correct or not?
Yes. Yes.
Now, if A be a point x comma y and B be the point x comma delta x. So this is the point which is x comma y. And this is the point we are assuming actually. Then B will be the point what? X plus delta x, y plus delta y, correct or not?
Yeah. Yeah.
Then the rate delta y by delta x is what? It is nothing but the slope of the straight line AB. The two
Hmm.
ways. One, though you know the rate measurement definition delta y by delta x.
Yeah.
But what it is geometrical significance? Its geometrical significance is it is the slope of the line AB. Correct or not?
Yeah.
Think about our coordinate geometry, straight line, right?
Hmm.
It is now this angle is alpha. This angle is alpha.
Yeah.
Now what is tan alpha? Tan alpha is nothing but suppose if you see that it is BC. Actually, this is the point C.
Hmm.
Okay, correct or not?
Yeah.
So BC by AC, that is equal to tan alpha, correct or not? All of you
Yes.
very clearly got it.
Yeah.
Now what happened is that so far though we all are aware of it, but what is the concept here? The point is that we cannot be precise, we cannot be very precise in terms of giving the definition of that rate because we do not know now how far is B from A.
Hmm.
Is B is very far from A, that means hypothetically, if we assume delta x relatively is large, then we cannot have a very good rate measurement. Think about. If I say that, today I studied for 5 hours, okay, and after 1 year, if I give a statistics and that day I studied for 8 hours, you really cannot find a good rate measurement.
Yeah.
I need to tell you every day, correct or
Mm-hmm.
not? That means the
Yes.
difference between 2 days is delta. But if I say today and after 1 year, then the difference is very high, na delta.
Um,
So that doesn't give you a very clear idea.
yes.
Why? The rate also varies between the points A and B. How come you know that between A and B how it is varying?
Yes.
Got it? Got the point now? From
Yeah.
the A to the point B, how it is varying? That we do not know.
Mm-hmm.
That's why what we need to do? We need to make that B very, very close to A. Correct or not? Got my
Yeah.
dear students? Okay.
Yes.
So, thus to know the rate of change of y at a particular value of x, say at a, we have to take delta x very, very small.
Mm-hmm.
I'm just giving the justification of why it has to be small.
Okay. Okay.
Because if it is not small, your rate measurement cannot be very precise.
Yes.
Correct, na?
Yes.
Suppose you say, sir, today I did a quadratic equation test in the online platform at KonarClasses.com and I got 5 out of 10, for example. And sir, after 6 months, I gave a test on the quadratic equation at the same platform with a different set of questions of similar difficulty level, and I got 8. I
Mm-hmm.
cannot really say very good rate measurement, right? Isn't it?
Mm-hmm.
But if you say every day, or sir, I'm doing a morning once, evening once, next day morning once, evening once, then by looking into this data, I can plot it, right? And
Mm-hmm.
then I can say what is the rate measurement.
Yeah.
So why all examples I'm giving? I'm that giving that 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 for a practical way or a for a practical value of x, to know the rate of change of y at a particular value of x, say a, we have to take delta x very, very small.
Mm-hmm.
Now, what is mean by delta x to be small in context to the diagram what you see in front of your screen?
Mm-hmm.
It says that the moment delta x is very, very small, as if that AB approaches to the as a straight line which is a tangent to the point A, correct or not? That was the straight line AB, right? Let me different color. That is the straight line AB, correct or not?
Yes.
The moment you take that delta x small, then AB is actually coming, and it actually come to AC. Let's give
Yeah.
a, oh, got it, na? It is give a C dash because here is already a point C, correct?
Mm-hmm.
So what I wanted to mean, I wanted to mean that, you know, that so what we get delta y by delta x equal to tan alpha.
Yeah.
We will see that as delta x is made smaller and smaller, the slope tan alpha of the line AB approaches to the slope of the tangent at A. Correct or
Yeah.
not?
Yeah.
Correct or not? That straight line AB as if transformed to the tangent at the point A to the curve. You know what is tangent? Tangent is nothing but a straight line which touches a curve.
Yes.
So the slope of the tangent at A gives the rate of change of y with respect to x at the point A.
Okay.
Got it? We'll
Yeah.
see later that tangent to a curve is nothing but the, giving the slope of that, the tangent. Okay, the slope of the tangent, tells us the value of, that rate of change of y with respect to x at that point of time. So what I say, I repeat the statement. Thus, the slope of the tangent at A gives the rate of change of y with respect to x, and that we denote as dy dx. Correct or not? So how we define it is dy dx. You will see. Let me show you this thing. How it is. Okay. Just a minute. Let me move it a little bit and bring this one. Please tell me, dear students, that you are able to view the screen very clearly.
Yeah.
Okay. So what I was telling, the rate of change, the rate is denoted by dy dx.
Mm.
Okay, and is denoted by what? That dy dx is nothing but delta y by delta x when delta x is tending to 0.
When delta x is
10 means very, very small. Small means what? Delta x has to be 0.
yes.
We are finding delta y by delta x, correct? No?
Yeah.
But we are finding that, as I said few minutes back, that is called the rate measurement, but that rate measurement may be practical when we make delta x very small.
Very small. Yeah.
In mathematics, what is meant by small? It should approach to 0, no? Then also we call it as a small.
Yes.
And
Yes.
that's why there is a term is called limit, LIM. Limit
Okay.
means is that it is a new term. We'll discuss later about this thing. Delta x is tending to 0.
Okay.
Delta x, then arrow 0 means it is actually tending to 0. Means it is approaching to 0. It cannot be exactly 0.
Huh, huh, huh.
Think about it. Exactly 0 means then B and A are superimposed. You really cannot make sense. Sir, I am in the same position.
Hmm. Yes.
Correct? Na? Suppose you give
Yeah.
a text now. I tell you now, give a text in the next 1 second again. How it is possible? You need to give some break, na?
Yeah. Yeah.
Practical thing you think of. That is why tending to 0.
Okay.
If you say delta x equal to 0, the moment we say delta x equal to 0, then the point doesn't come into the picture at all. There is no rate measurement. We are in the same position.
Okay. Got it.
Okay. So, dear students, all of you, could you tell me that you are understanding clearly, dear students?
Yes.
Yes, sir.
Yes, sir.
Okay.
Yes.
Great. So, that is why we define, this is what we define is that dy dx. Remember, I am not saying dy by dx. Okay. Never say dy by dx. It is dy dx. Why? It is a new operator. We'll see later. It is a differential operator. Okay. So ddx, d, apparently what we say is that this is known as ddx. This is nothing but an operator. The way you see operator, plus, minus, multiplication, division,
Yeah.
logarithm, exponential. This is also an operator, and it operates on an dependent variable y. And it gives some result that will actually help you to understand how y is changing with respect to x.
Okay.
Addition help us to add, subtraction help us to subtract, multiply help us to understand one quantity is how much time of the other quantities. Similarly, differential operator help us to understand how the rate measurement is happening, how the other quantity is changing with respect to the other quantity.
Okay.
Correct?
Yes.
So now, then what we understood? Never say dy by dx, dear students. Okay.
I do.
Okay. In few years, in India, I have seen this thing. So in future, if you go to abroad to study, and because of whatever you learn today, that actually remains with you, right? So
Yeah.
you dy by dx in front of others, it doesn't look good. Because literally, if you say dy by dx, as if like dd got cancelled, right? Literally. Become y by x. No, that doesn't make sense. Absolutely not. But I can say delta y by delta x. I never say delta y delta x. It is delta y by delta x. Exactly, we are dividing. And dividing in such a manner that the denominator is actually tending to 0. But what we get out of that, that is actually dy dx.
Okay.
So now, as this is the case, what you see, I marked in that green rectangle, dy dx is equal to limit delta x tending to 0, delta y by delta x. That means what? The actual value of dy dx should be equal to delta y by delta x plus epsilon, another small value. Correct or not? Why so? Because it is a limiting value, na? If I say, hey, find a limiting value of 2, then you can say it is 1.999. Correct or not?
Yeah. Yeah.
What is the limiting value of 2? 1.999.
Yes.
Someone else can say, so no, not it is 1.999, 1.99999. Correct? But it is
Yes.
not exactly true. You are not supposed to tell 2. Suppose I'm giving. Or someone can say, sorry, that the approximate value of 2 is 2.001. Someone can 2.001, someone else can say 2.00001, someone can say 1.999, someone can say 1.99998. All are near to 2, but not exactly 2. Correct or not, dear students?
Yes.
So that is what is called limiting value. So what we find dy dx equal to delta y by delta x plus epsilon, where epsilon is a very small quantity.
Okay.
Correct or not?
Yes.
Then what we are doing, we are multiplying, then that is the step. The next step what we are doing, we are multiplying by dx. So what we get, delta dy is equal to delta y by delta x into dx plus epsilon into dx. Got it, not dear students?
Yeah.
Now there is a very interesting thing. Epsilon is what? Very small quantity.
Yeah.
Dx is also a very small quantity.
Mm.
When you multiply two small quantities, the resultant will be even smaller.
That's wonderful. Yeah.
Correct or not? If you
Yes.
multiply 0.01 with 1, you will get 0.01. But if you
Yes.
multiply 0.01 into 0.001, you will get very, very small number. Now,
Yes. Yes. Yes.
so in an approximation sense, we can eradicate this particular thing, If
Okay.
you see, because of this logic, as epsilon into delta x is very small, we can remove this. That's why
Okay.
in the next step, what we wrote dy is equal to delta y by delta x into dx. Correct or not?
Yes. Got it.
All of you are getting my point, dear students?
Yes. Got it.
So what is that? Now, if you look into this I gave an equation 1, that delta dy is equal to delta y by delta x into dx.
Okay.
From this equation 1, we see that if the function y increases with an increase in x, dy dx is positive. Correct or not?
Yeah. Yeah.
If when delta y, because both delta y and delta x is positive,
Mm.
think about. Yes, let me pull that one, then you will discuss. Let me pull that particular statement, then you will have a discussion. Just a minute. So, if you look into from the above equation 1, we see that if the function y increases with an increase in x, that means both delta y and delta x are positive.
Yes.
Correct or not?
Yes.
Then we say dy dx is positive.
Mm-hmm.
And when the function y decreases with an increase in x, dy dx is negative.
Yeah.
Delta y is negative where delta x is positive. Let me give you a practical example.
Mm.
When you are moving with a very good speed in a car and then there is a brake is being pressed, what happened? Velocity is actually decreasing.
Decreasing. Yeah.
So velocity decreasing, but previous velocity was, if you make a final velocity minus initial velocity is negative, right?
Yes. Yes.
Correct or not, dear students?
Yes. Yeah.
But your time is positive, na?
Yeah. Time
Suppose
is
at time 2 seconds, the velocity was 50 kilometer per hour.
Mm.
At time 3 seconds, the velocity become 45 kilometer per hour, for example.
Mm.
Then what is the change in the velocity? 45 minus 50, that is minus 5.
That's 5 kilometers.
But what is the time changes? It is plus 1 second.
Mm. Yes.
So that's why it is negative, and the rate of change of velocity is known as the acceleration. So acceleration is negative. That means what? It is called deceleration. Correct or not, dear students?
Yes.
So that is why deceleration is also known as negative acceleration.
Yeah. Yeah.
You can look into the same phenomenon in different angles, from your fundamental concept, from mathematics, and from mathematical equation here, what you see. I hope you get a clear idea about what is rate measurement and why we need to bring that the concept of dy dx. Again, we'll see later that ddx, is nothing but an operator. That is called differential operator. Correct?
Okay.
The way we see the logarithm is an operator. The way we see plus, minus, multiplication, division operator, every operator has its own purpose. Similarly, the differential operator has a purpose that it will help us to find the rate measurement, how the other quantity is changing with respect to the other quantity. Correct? Now think about a very practical example, that as I said that dy dx is positive. What you understood about the dy dx? We understood about the dy dx is nothing but it is the slope of the tangent of the curve at that particular point, dear students, isn't it? Correct or not? So now let's look into this. After that, we'll go with some formulas. Suppose this is the coordinate axis. And suppose I draw another straight line. Okay. Now, so what I wanted to mean is that this is, this is origin. This is positive direction of x-axis. This is negative direction of y-axis. This is positive direction of y-axis. This is negative direction of y-axis. And we have a curve. What curve we have? We have a curve something like this. Let me draw the curve a little better. Okay. Now, let's take a point in this curve. Correct, no? Got it? And the curve actually goes like this, for example. So, let me first complete drawing the curve. Okay. Or let me draw a little more practical manner. Just a minute. This is negative direction of y-axis. And let me draw the curve something like this. Suppose this is our curve. Now, let's take two particular points on the curve. One point is here. And the other point is, suppose, here. Correct, no, dear students?
Yeah.
So suppose, this is the point I defined as the point A. And this is the point is B.
Yeah.
Think about, let's take a practical. It's the curve looks like the shape of a bowl. Correct or not?
Yes. Yes.
Suppose you release a ball just above the point A. Then what will happen? The ball will go and come to the down, and suppose this is the point C. And then again go to B, and it will not able to go far, no? Because the velocity will decrease. Then again it will come back, it will go to A, like a kind of a periodic motion. Correct or not?
Yes. Yes.
Now think about at the point A, if you draw a tangent, suppose x-axis is time, correct, na? Then what will happen? This is the slope, right? The tangent.
Yeah.
What is the value? This value is, suppose this value is alpha. Alpha is acute, na?
Yes.
And now let's go back to our trigonometry class. That acute angle of a tan is always positive.
Positive. Yes.
So that's why it says that the velocity will increase, na, dear students? Correct or not? Because alpha is positive, alpha is acute, tan alpha is positive.
Yeah.
So tan alpha is positive means what? It is slope is positive.
Yeah. So dividing.
Rate measurement is positive.
Positive. Okay.
But if you look into the point B here, and if you draw a tangent here in this point O1, what is this angle? This angle is beta. But here beta is obtuse.
Obtuse. Yeah.
Okay. Obtuse means, between 90 to 80 degree, 180 degree.
180.
And tan of obtuse angle is negative. That means dy dx is negative. If dy dx is negative means what? Rate measurement is negative. That means what? That with respect to time, my velocity is actually decreasing.
Yes.
Different angle you can look into it. But I do not want to go into more depth and depth, because we'll go as time goes by. In the one class, we will not do, it is not good practice. Okay. So, what is the fundamental definition then what we are getting? Whatever we get from the rate measurement. Now, from a mathematical point, what we can say? Suppose y equal to fx, that was our curve, na, function.
Yeah.
So now delta x, we found it out. So then what we find, dy dx, dear students, dy dx is also known as f dash of x. Also, got it?
That's okay.
F dash, that is another way of saying. So limit of delta x tending to 0.
Hmm.
And what we are getting? We are getting delta y. Delta y means what? F of x plus delta x minus fx. Correct or not?
Delta
Delta y, if you see in the above curve, what is the point B? Y plus delta y.
y plus delta y. Yeah.
Correct? Huh?
Yeah.
So y plus delta y means what? So that's what we did. The value of the function at the point x plus delta x, that is f of x plus delta x. Correct or not?
Yeah.
And divided by delta x. Whatever the value of this limit is called the f dash x. Correct or not?
Okay. Okay.
It is delta y. What you see, f of x plus delta x minus fx is nothing but delta y. If you look into the curve, look into once more. That is delta y, na? This one. That is delta y, correct?
Yeah. This is delta y.
B is what? X coordinate of B is x plus delta x. So that means its y coordinate should be y f of x plus delta x.
F of
F of
x.
x plus delta x, this one.
Yeah.
And this one will be what? F of x. So their subtraction is BC, na?
Yeah.
And that is why we wrote this thing, correct or not?
Okay. Okay.
Absolutely clear?
Yeah. Yeah. Yeah.
So this is called the fundamental definition of the the differential coefficient or rate measurement, dy dx, f dash x, multiple ways you can say.
Okay.
Or not clear? Any doubts so far, dear students?
No, sir.
Now there are some standard functions whose differentiation we must be aware of. There are some important function and there are some standard functions. Correct, no? Got my point? Okay. So derivative of some important functions that I'm going to show you now. So that I'm going to show you in the next page. So these are the differentiation of the standard function you must be aware of. Okay, I'm going to the next page. Okay. Got it? So what is that? Here it says that ddx of x power n is equal to n into x power n minus 1. Let's look into one by one. Huh? Fine, dear students?
Yeah.
So what does it mean? Let me give a practical example. Is that it says that suppose ddx of x power 3 is equal to 3 into x square. Got it? Now you can ask, sir, how you got it? Want the formula, but can you prove it? Definitely we can prove it, but this is not the right class for that. Why? Because for that we need to go to more depth about the limit and how to find the limit of standard function. Then we'll compute this thing. Why I'm saying so, dear students? Because of this, we need to find this value. Just a minute. We need to find this value. F of x plus delta x minus fx by delta x and their limiting value. Got it, no?
Okay.
So that we are not discussing today. We are discussing only the rate measurement part of the differential calculus. And you will find rate measurement is there every topic in, almost every topic in physics in your level, at your level.
Okay.
Okay. So this concept has to be used very, very clearly. And you will find when you start solving the numerical problems in chemistry, physics, okay, in kinematics, dynamics, laws of motion, rotational motion, and other cases also, you'll always see that the concept of rate measurement coming. The moment rate measurement is coming, you need to apply these formulas. Suppose you got a curve y equal to sin x. Unless you find what is dy dx, that means ddx of sin x. There you need to apply the concept of ddx of sin x is equal to cos x. Did you get my point, dear students? Correct? So ddx of x cube is equal to 3x square. ddx of sin x equal to cos x. ddx of x power n is equal to n into x power n minus 1. ddx of cos x equal to minus sin x. ddx of tan x equal to sec square x. ddx of cot x equal to minus cosec square x. ddx of e power x is e power x. All I am repeating. Your task till we are starting our class tomorrow is that you need to remember this thing. I will ask all of a sudden, okay?
Okay.
That is your task. ddx of sec x is equal to sec x into tan x. ddx of cosec x is equal to minus cosec x into cot x. ddx of ln x means log, okay, is equal to 1 by x, okay, log with a base e. Log, we briefly discuss about log, na? It can have different base. It can have a base 10, it can log b to the base a. Here it is log x to the base e. Then ddx of sin inverse x equal to 1 by square root of 1 minus x square. ddx of cos inverse x equal to minus 1 by square root of 1 minus x square. ddx of tan inverse x is equal to 1 by 1 plus x square. Dear students, recall the tan inverse in the vector direction, correct?
Yeah.
ddx of cot inverse x equal to minus 1 by 1 plus x square. ddx of sec inverse x equal to 1 by mod x into square root of 1 plus x square. ddx of cosec inverse x equal to minus 1 by mod x into square root of 1 plus x square. ddx of a power x is equal to a power x into log a to the base e, that is ln a. And ddx of log x to the base a is equal to 1 by x into log a to the base e. All these formulas you need to remember. Now, in the class tomorrow, we will discuss the algebra of the derivative of functions. What are the algebra and other different, functions, how to make differentiation of different type of functions, that we will see tomorrow. Okay.
Yes.
With this, I would like to conclude the class today. But before that, if you have any smallest query, please do let me know. So far, whatever I discussed.
Actually, it's fine.
Perfectly fine, dear students, all of you.
Yes, sir.
Okay, great then. Thank you very much. We'll have class tomorrow at 9:30 a.m.
Yes.
I'll send you the class note and and the recorded session of today's class in another 10 to 15 minutes.
Yes, sir. Sure.
All right. Thank you very much.